Yeah, warm welcome to one and all. Myself Prasad, belongs to Mechanical Department, Assistant Professor, K.S.Rangasamy College of Technology, Tiruchendur. Today we see about the topic on Introduction to Additive Manufacturing. The first thing, what is meant by manufacturing? So the manufacturing is a process in which the raw materials are transformed into finished products. So whether the raw material will be in solid form, liquid, or then powder form, it can be machined or do some equipment special operations, and we can get a final output product. So it is the normal conventional machining process. So in conventional machining process, the raw material will be in solid form. So whether we can require a pin or cap like thing, we can do an machining operations. So in machining operations, the material can be removed and we can get a final output product. So it is the conventional machining process. Then additive manufacturing. So all of you know about that printer. The same thing will be done in the additive manufacturing. So in additive manufacturing, it is also named as 3D printer or rapid prototyping. So the process involved in this additive manufacturing is there can be create a three-dimensional objects by adding a successive layers of materials. Like for example, in 2D printer, like a paper printer, the document can be directly printed directly from that computer. The same thing, whether we can create a model and that model can be directly printed from the computer. So it will take much amount of time to complete a project. So it is a current now it is in current trending technology in now the technology has been increasing properly in recent years due to the ability of produce complex geometries and customized design with high precision, because we can whether we have to manufacture complex problems or complex design components, it required the mold cavity and then draft angle. We can give them draft angle and then draft angle like things, and then it will take much amount of time required to become a prototype. So it can be neglected, and also the time consumption and the cost wise will be reduced. Now so that reason the technology will be popular in recent years. The technology was developed in the year 1980s. Now it will be updated. Then it can be the additive manufacture can be classified in three ways. That is based on the solid, and then that is the raw material. Based on the raw material, the additive manufacturing process can be classified that. So based on the raw materials, like the raw material will be in solid form or liquid form and then powder form. Based on that, that process can be classified into wet photopolymerization, material jetting, binder jetting, metal extrusion method, and then direct energy deposition, and then sheet metal lamination, and powder bed fusion technology. So the first thing was the wet photopolymerization. So in wet photopolymerization involves the we can use a liquid as used as a raw material. So from that raw material, liquid resins, we can pass a laser light or photovoltaic light, the weather sources. The light sources will be hit on that liquid resins, it will be solidified there. So it is the process called wet photopolymerization, like an photography. Whether the UV rays will be passed on the photovoltaic film, it will be will be formatted. Like the same thing, the resin will be in photovoltaic resins. Whether we have to pass in ultraviolet rays, well, the ultraviolet rays will react with that resin and it can be solidified that. We can get a final output product. Based on that photovoltaic polymerization, we can use the SLA method. So the SLA is means stereolithography is the method. The another name for photopolymerization is called as the SLA method. Then material jetting. So in material jetting, we can use an ink like an ink, the inkjet technology, to deposit droplets of material into a built platform. Like we have to spray and nozzle type. We can spray the raw material will be in liquid form. we can spray it, and then we can use an ultraviolet rays or laser. We can use an ultraviolet rays to solidify that droplets. So the metal jettings are uh, used for very complex geometries and also for fastest production also. Then binder jetting. So the binder jetting is similar to metal jetting. So in binder jetting the process, instead of using an inkjet, we can spray the binder materials. That means the raw material will be in powder form, the raw material will be in coated over the bed. We can spray the binders, spray the like in very tiny particles. We can spray on that coated up bed, or like the raw material will be poured on that bed, and we can be sprayed the particles. We get, that means we can spray the binder jets. The binder will be, the binding agent will be, so that means reacted with the powder, it can be created solid particles. It is the binder jetting process. So the raw material will be in polymer or metal form. It is the binder jetting process. Then next thing is powder bed fusion technology. That is, with the same thing, instead of using the binder jet, we can use a laser beam to binding the particles. So in binder jet technology, in binder jetting, the raw material will be in powder form. That means the raw material will be in only for polymers like plastics. The plastic metals can be only used in this binder jetting process, because we can use the metal powder. The binders will not react with the metal powders. So whether we can print a component in metal 3D printing, metal printing, we can go to for powdered bed fusion technology. So another name for powdered bed fusion technology is called as metal 3D printer. The same thing. The metal 3D printer like SLS and then SLM. The SLS is the selective laser sintering, and SLM is the selective laser melting technology. That means they can sinter, the particles will be fused and we can get it, otherwise it can be melted and to form in solid form. So in powder bed fusion, the powder will be fused together by melting or sintering, and we can get in final output products. The another name, it is also called as the metal 3D printer, powder bed fusion technology. And then next thing is direct energy deposition method. So in direct energy deposition method, the raw material will be in solid form. Directly we can melt it and solidify it. The direct energy deposition or direct metal deposition are same thing, as well as its name, it is called FDM and then DLM and DDM, like that is DMD, direct metal deposition and then fused deposit modeling, like thing, or method, like thing. So in this method, the material will be in solid form or in liquid form, solid form or in powder form. The metal will be melted, or the raw material will be melted and directly deposited on the bed. It is called direct energy deposition method. Then next thing is the sheet metal lamination or laminated object manufacturing technology. So in that process, the raw material will be in sheet form, like in the very thin sheet. The thickness will be around 0.00025, I think, the thickness of the sheet. So that sheet metal will be rolled over the bed, or it can be passed over the bed with the help of laser light. The sheet will be cut based on our requirement. With the help of laser, the sheet will be cutted and they can be binded it. So during this continuous process, we can get a final output product like an image. It is a heat roller, like it is the process involved in sheet laminate object manufacturing method. So these are the process. These are the classifications of additive manufacturing. So I already told that the components will be directly printed from computer. The other we can create in model, directly that printed model will be directly printed. So before that we can do some operations. That what are the some pre-processing steps are required to print the components. The pre-processing steps are called as process involved. So what are the process involved? It is the methodology involved in this like what are the process involved or methodology involved in the additive manufacturing. So the first thing is whether we can create a CAD model. So based on our requirement, we can create a CAD model by using modeling softwares like Creo, CATIA, and then Fusion 360 or anything. Like we can use an open source also, open source software also like a Blender also. The any 3D modeling software can be used. We can create a model. After that, the created model will be converted into an STL format. That means .stl format, that is called stereolithography or stereolithography file format. Once that is an imaginary format. Once the model was saved in that format, after that, that model will be, that image or that file can be sliced it, because in additive manufacturing technology the materials will be added in layer by layer method. So whether we have to model a component around over 600 length and 400 length, that component we can't directly print it in the huge block in a single mode. That means we have to slice into a number of layers. After that it can be uh, after that can be printed now. So for slicing purpose we need in slicer software. The slicer softwares the open source softwares are available, and also based on the machines the softwares will be provided. So the open source softwares are Slicer, and then Cura, and then create board, like thing. These are the open source softwares. So the most of them they can be used Cura for slicing purpose. So in slicing software, we have to define based on the, for example, in FDM, that means in future deposit modeling, we can the output will be the raw material will be solidified, and nozzle will be placed on the heating bed. So the output, the layer will be coming out from that nozzle. So based on that nozzle diameter, we have to define the layer thickness. Whether we have to the diameter of the nozzle 0.4 mm now, that layer thickness will be in the half of this diameter, like the 0.2 mm. So the layer thickness will be in 0.2 mm. So in slicing software we have to slice based on that design, and then infill ratio and orientation, support layers are needed, lighting, all the things will be considered, and we have to slice the components. So slice the given model into a number of layers. After the output of the sliced, like in slicing software is the G codes. The G codes are directly feed into the machines. So the machines can't read out the machine language is only the G codes, miscellaneous codes now. So it can't read the files. It cannot read the component drawing components or file. The machine language are we can get it like coordinate systems. Based on that G codes, the machine will run it, and we can get a final output product. So this is the process involved in this additive manufacturing. So in all this process, the slicing software is required. So based on that means it depends upon the layer thickness, we have to define it. So the layer thickness can be also varied now. The next thing, what are the materials used in additive manufacturing? So the basically it can be classified into three categories. It is like solid form, liquid, and then powder form. So the solid materials are granulars. It can be used for solid 3D printing, like so the solid print, that is the direct metal deposition method or FDM technology. So in solid printers are like granular or filaments can be used. So most of them they can be used polymers. The polymers are ABS, that is acrylbutyl syndrome, and then polylactic acid, HIPS, nylon, polycarbonate, polyethylene, polyether ether ketone like PEEK, and composite minerals also can be used like carbon fiber, that is the carbon plus PLA and then carbon plus ABS, like all the thermoplastic material, that is the polymers can be, most of the polymers can be used in this machine in terms of the solid forms. For in liquids, they can be used epoxy articles and then silicons, acrylics, like this kind of silicon based materials can be used for um, liquid 3D printers, because because whether we have to pass then ultraviolet rays, that is we can pass the ultraviolet rays, the raw material will be sulfates. So for that purpose, we can, most of them they can be used for and use silicon based liquid jets. So whether it can be used in SLA or binder jetting or metal jetting, most of them they can be used for this problem. And then in powder form they can be used in polymides and then granulars, glass fibers, like things, based on in polymer sets, that is they can be used. Whether also can be in metal 3D printing, they can be used, the metal will be in terms of powder form, whether we can use aluminum or silicon or cast iron or bronze, as well as titanium also can be used for metal 3D printing. So based on these are the classification, that means based on that it can be used for it now. So next thing, the main thing. So we have seen about the process, based on that raw material, the process can be classified. So before choosing the process, in which kind of process can be, that means based on our requirement, which kind of process is suitable for me. So before that we have to select the process parameters, that means uh, based on that means the size of the component and also desired solutions, complexity of the problem, surface finish and the mechanical properties, as well as the infill ratio. And then these are the, like, some of the process parameters, some of the factors will be considered. So for selecting that, uh, selecting the techniques or selecting the um, class process parameters, like things. So these things, yeah. Advantages and the limitations. So in 3D printing, some of the advantages are available and also some limitations are also available. The advantages are free from its design, complexity of free, and the potential elimination of tooling, lightweight design, elimination of the product steps. Same thing. That means without any jigs and fixes or mold design, like things, we have to create an, we have to develop an component is the main thing. And also not free from its design, whether we have to do any modification, same thing, it will be done in a simple manner, like complexity, light in weight, whether we have to use in most of the 3D printings they can be used for composite materials or for manufacturing component, like that. And eliminate the production steps. That means elimination of production step means, so normally in conventional machining process, the production steps includes starting from design to and ending with quality checking. That means after the design was approved, the what are the based on the design we have to define it. What are the process involved in that machine, and how will it be define it? Whether which machine is pre lighting, and also we have to check it the quality. Like all these things can be eliminated, because in 3D printing they can be create a model in perfect manner, like that. And the limitations or advantages are disadvantages are the build rates. That means whether we have to manufacture a component single, that means we have to print a component as small cube of 10 centimeter into 10 centimeter, and with a cube of 10 centimeter it will take much amount of time, it will take around 1 day to complete it. So that is the slow build rates and high production cost. So it is not suitable for the production process. So that means the slow production and also the cost base will also increase. Considerable effort required for application design. Most of the things it can be used for prototype model. So it is not suitable for product design also. And limited component sizes. That is uh, in any processing like VLA, sorry, FDM and then laser cutter, laser sintering, and then wet photopolymerization. The bed size is fixed, so we can't create a component in a huge size like a gear of 1 meter and also the gear of 2 meter like this. We can be produced it. We can be manufactured within a so maximum we can able to create a component around maximum size will be around maximum 600 or to 700 mm. Beyond that we can't to produce that component. So it is the main drawback of the lens component system. So then applications. So the where it can be used. So in recent days, the additive manufacturing or 3D printing or prototyping plays an already told them it can be placed a major role major role in our areas. So that can be used in aerospace industries, automotives, healthcare, and then fashion technology. So in automotive or aerospace industries, it can be used for creating lightweight and complex geometrics for aircraft components and also automobiles. Whether instead of using a sheet metal, you can use the composite materials or other things. In healthcare, so in healthcare, the additive manufacturing can be used for create or developing medical implants and the devices as well as produce model for surgical implants and the tissue also tissues will be like 3D components all can be 3D bones 3D skulls also can be printed and can be adapted for further operation also. So in automotive industries, they can be used for prototyping and small scale also. It can be the most of the things that additive manufacturing can plays a major role in all industrial areas as well as the thing.